This is the video for using the quadratic formula to find the roots. At the end of this lesson, you will be able to find the roots of a quadratic function, even when you cannot factor the function. You will use the quadratic formula to find the roots in today's lesson. At the top of your worksheet, there is a little mini do now here, so I'd like you to pause the video and graph this function. You can use your calculator, so make sure you have that out and ready to go so you can make your table of values. Please pause the video, make your table of values, and create your graph. Also, please label all of your key features when you create your graph. So at this time, please pause the video. Okay, so here's the graph of f of x, where the vertex is at 1, -9. The axis of symmetry is x equals 1. And I have two arrows here pointing to the roots. You'll notice here, depending on how you created your graph, that we don't actually know what this value is or what this value is for the roots. Now I know mine looks like over here that it crosses at a nice spot on the graph at a whole number, but we know it doesn't. Otherwise, wouldn't it show up in our table? -1 really goes to 7, and 0 goes to -5. So if I drew my graph a little bit more carefully, I know that my root would really be somewhere in between 0 and -1. Where over here, I could see my root is somewhere in between 2 and 3. So at this point in the game, I don't actually know what the roots are. I know that there are 2 of them because it crosses the x-axis twice. Okay, let's look at the questions that follow. What are the roots of f of x? Well, for right now, I'm not really sure, so I'm just going to write that down here. I'm not sure. And I'm not sure because they are decimal values. They're not showing up in my table. But I can see them on my graph. So if we had to estimate what the roots were, well, we said before, where I have my little yellow highlights, this root on the left is somewhere between 0 and -1, so maybe your graph looks a little bit better than mine. I'm just going to predict, remember the roots are in curly brackets, a solution set, that maybe it's -0.5. And let me guess this one on the right. I know it's between 2 and 3, so mine looks like it's a little bit closer to 3. Maybe I'll guess 2.75. Okay, so these are just estimates. We don't actually know them. I'm just trying to eyeball them based off of my graph. Okay, so that means that this quadratic function has roots. I just don't know them just yet. So today what we're going to do when we're having trouble finding the roots of a quadratic function from a graph, and if we try to do this algebraically, we probably could factor it, but today we're going to learn a new way how to find the roots. And this way is going to come in handy in the next few examples that we're going to check out in class tomorrow. So we are going to now learn what is called the quadratic formula. When we use the quadratic formula, the first thing we're always going to do, just like when we were finding the axis of symmetry, is identify A, B, and C. So the quadratic formula is down below right here. Okay? Where this x is really representing the roots. Remember, our roots are x values. Our axis of symmetry is a linear equation. So this formula, I know it looks really complicated. There's a lot going on here, but I'm going to show you an easy way to remember this formula today. So I would read this as x equals -b, this is plus or minus, the square root of b squared minus 4ac, all over or divided by 2 times a. So to find the roots algebraically, the last few days we have been factoring, or today you are going to use the method of using the quadratic formula, which is this equation right here. Okay? So you might be wondering, how will you ever remember this formula? And luckily enough, this formula is actually on your reference sheet. So we'll check this out tomorrow where we can actually see this formula, but it is on your reference sheet that you got when we were working in our sequence unit. There's also another way you can remember this formula. There's a really catchy song that I'm going to share with you now. And what you can do is type in this website here at the bottom of your page very carefully, or you can follow along with me and I will play the video now for you. Okay? All right. Here we go. Here's the song to the tune of Pop Goes the Weasel to help us remember the tricky quadratic formula. Here we go. All right, so that is the quadratic formula song. We will be singing this for the next 2 days. So play that over and over again until you catch on. Remember to watch it. You can go to that website at the bottom of your page there, or feel free to go to YouTube and type in quadratic formula song. There are some other different variations out there that you can check out as well. Extra bonus points if you can come in tomorrow singing that song without looking at your paper. All right, so let's get back to our original problem in the do now, where we were unsure of these two roots because they were decimal values. So what we're going to do now is actually use the quadratic formula to see if we can find those roots. We'll also check out and see how good our estimates were. Here we go. So let's find the roots, the same function from the do now, using the quadratic formula. So I am going to write down the quadratic formula, and I like to sing it to myself to help me write it out. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you have the quadratic formula. Let's identify a, b, and c first. I hope now you're seeing why it's important to identify the c, because we are going to use them in the quadratic formula today. A is 4, b is negative 8, and c is negative 5. So I'm going to plug in my a, b's, and c's everywhere I see each of those letters in the quadratic formula. Remember, it's very important to put them into parentheses. So here I go. X equals negative, b is negative 8, plus or minus the square root, b is negative 8 squared, minus 4 times a is 4, c is negative 5, and just make sure you extend this all the way across, all over, so a big division bar, 2 times a is 4. Now we need to evaluate this, so I'm going to break it down like this. X equals negative 1 times negative 8, that's positive 8, plus or minus. What I'm going to do now is I can actually input everything that's under the square root sign into my calculator at once. That way I can get the value that's supposed to be underneath the square root sign. So take a moment now and make sure you have your calculator ready, and let's input this together. Alright, so I'm going to input with parentheses and all. So negative 8 parentheses squared minus 4 times 4 times negative 5. Hit enter. and we get 144. So now I can, under the square root sign, I will input, all of that simplifies to 144. All over 2 times 4 becomes 8. I'm going to keep going, and now I'm going to evaluate the square root of 144. So x equals, do you know what the square root of 144 is? If you said 12, you are correct. Whoops. Since the square root of 144 is 12, we just write 12 all over 8. Now we're ready to split things up. And here's how we do it. On the left-hand side, I'm going to write x equals 8. Now right here, we had plus or minus 12. I like to make the one on the left use the plus sign, all over 8, and split the one on the right to have 8 minus 12, all over 8. So that was our splitting point. We went as far as we could, and then it was time to split things up. I'm going to continue simplifying. So we must do the numerator first. X equals 8 plus 12 becomes 20 over 8. Over here, x equals 8 minus 12, negative 4 over 8. I think we have one more step left. Let's see. X equals 20 divided by 8. We should get 2.5. And over here, x equals negative 4 divided by 8. Or if I simplify, I will get negative 1/2. Yes, you may write negative 0.5. That is equivalent. And here we have it. These are our two roots. We got x equals 2.5 and x equals negative 1/2. I'm going to list my roots in a solution set. And let's take a look back at our do now and see how good our estimates were from before. Let's see. I had predicted that the root on the left was negative 0.5. And yes, we got it. Okay, it really is supposed to be in between here if I graphed it a little bit more accurately. And the root on the right, I had predicted mine to be about 2.75. But we can see, in fact, according to the quadratic formula, it's actually 2.5. So we are going to continue using the quadratic formula in class tomorrow. Remember, we use it to find the roots. We don't have to use the quadratic formula, but sometimes it's going to work out very nicely, and sometimes we will have to use it because factoring won't work out so well. So please play that song again a couple times, practice the quadratic formula, and let's see if you can come in tomorrow knowing that song. Thank you.